tropical cyclones, often known as typhoons or hurricanes, are powerful circular storms with low air pressure, strong winds, and heavy rain that develop over warm tropical oceans. A tropical cyclone produces winds that exceed 119 kilometers (74 miles) per hour by drawing energy from the sea surface and sustaining its strength so long as it is over warm water. Extreme conditions can result in winds exceeding 240 kilometers per hour, 150 miles per hour, and gusts above 320 kilometers per hour, 200 miles per hour. Along with these powerful winds, there may be torrential rains and a destructive phenomenon called a storm surge, which causes the sea surface to rise by up to 6 meters, 20 feet, beyond typical levels. In tropical and subtropical regions of the world, cyclones pose a major threat to coastal areas due to their tremendous winds and water levels. Every year, cyclones hit places as far apart as the Gulf Coast of North America, northwestern Australia, and eastern India and Bangladesh during the late summer months, July-September in the Northern Hemisphere and January-March in the Southern Hemisphere. Different regions of the world have different names for tropical cyclones. Typhoons are storms that form in the western North Pacific and are centered near the Philippines, Japan, and China. Hurricanes are storms that form in the North Atlantic Ocean and the eastern North Pacific. They go by other names in the western South Pacific and Indian Ocean, such as strong tropical cyclones, or just cyclones. The same kind of storm is referred to by all of these distinct names. Tropical cyclones are small, circular storms with winds swirling around a core of low air pressure. They typically have a diameter of 320 kilometers, 200 miles. The Coriolis force, a phenomena associated with the rotation of the Earth, as well as its low-pressure core, are what propel the winds. Because of this, tropical cyclones rotate counterclockwise, also known as cyclonic, in the northern hemisphere and clockwise, also known as anticyclonic, in the southern. 3 areas can be identified in a tropical cyclone's wind field. The first is an outer zone that resembles a ring, often with an inner radius of 30 to 50 kilometers and an outside radius of roughly 160 kilometers, 100 miles, 20 to 30 miles. The winds in this area pick up speed uniformly as they move toward the center. The second area, the eye wall, when wind speeds are at their highest, is normally 15 to 30 kilometers, 10 to 20 miles, from the storm's center. The interior region, known as the eye, is surrounded by the eye wall, where wind speeds suddenly drop and the air is frequently quiet. The eye, a center region with clear skies, warm temperatures, and low air pressure, is a defining characteristic of tropical cyclones. The average atmospheric pressure on Earth's surface is 1,000 millibars. However, it is normally approximately 960 millibars at the center of a tropical cyclone, and in a very powerful super typhoon of the Western Pacific, it may even drop as low as 880 millibars. Along with the storm's low-pressure center, the pressure rapidly varies throughout the storm, with the most of the variance occurring close to the center. On the other hand, the eye's internal horizontal winds are weak. Additionally, as air is drawn into the eye wall at the surface, there is a slight sinking action, also known as subsidence. Temperatures at the center of a tropical cyclone are around 5.5 degrees Celsius 10 degrees Fahrenheit higher than in other parts of the storm as the air warms and somewhat compresses as it settles. The eye of the cyclone is typically cloud-free because warmer air can hold more moisture before condensation happens. Reports of oppressive or sultry air inside the eye are likely psychological reactions to the eye's abrupt transition from windy and rainy circumstances in the eye wall to calm ones. An eye wall is the most hazardous and destructive component of a tropical storm. Here, winds are highest, rainfall is most abundant, and deep convective clouds rise to a height of 15,000 meters from the Earth's surface, 49,000 feet. The above-mentioned fast variations in atmospheric pressure near the eye, which produce a significant pressure gradient force, are what propel the strong winds. The height at which winds are actually at their fastest is around 300 meters, 1,000 feet, above the surface. Friction slows them down closer to the surface, and a weakening of the horizontal pressure gradient force beyond 300 meters weakens them. This slowing is connected to the storm's temperature structure. The center of a tropical cyclone has warmer air, and because of this, the pressure there drops with height more slowly than it does in the surrounding environment. The horizontal pressure gradient weakens with height due to the reduced atmospheric pressure differential with altitude, which in turn causes the wind speed to drop. In addition to slowing down the wind, friction at the surface also causes the wind to shift inward into the region of lowest pressure. By expanding to become cooler as it enters the low-pressure eye, the air draws heat and water vapor off the ocean's surface. The eye wall exhibits the highest vertical wind speeds in the storm, reaching up to 5 to 10 meters, 16.5 to 33 feet per second, or 18 to 36 kilometers, 11 to 22 miles per hour in areas of maximal heating. Even though these velocities are substantially lower than the horizontal winds, updrafts are necessary for the survival of the massive convective clouds that are lodged in the eye wall. These clouds contribute significantly to the tropical cyclone's torrential rainfall. The eye is wider aloft than at the surface due to the upward migration of air in the eye wall. The amount of angular momentum that the air has as it spirals upward depends on both the distance from the center of the cyclone and the wind speed surrounding the center. As the storm rises, the air must go further out from the storm center since wind speed diminishes with altitude. The top boundary of the troposphere, located about 16 kilometers, 10 miles above the surface, is where updrafts reach the stable tropopause, where air flows outward. This outward flow is diverted by the Coriolis force, which results in an extensive anticyclonic circulation above. As a result, the horizontal circulation in a tropical cyclone's upper levels is the polar opposite of that in its lower levels. As a circulation system matures into a mature tropical cyclone, it passes through a series of stages. The storm starts out as a tropical disturbance, which usually happens when a weak circulation can be seen in a band of loosely grouped cumulonimbus clouds and an easterly wave. When the storm's wind speed reaches 36 kilometers per hour, 23 miles per hour, it is deemed a tropical depression. It is said to as a tropical storm if the circulation keeps getting stronger and the wind gusts exceed 63 kilometers per hour, 39 miles per hour. The storm is deemed to be a tropical cyclone whenever the top wind speed reaches 119 kilometers per hour, 74 miles per hour. The heat and water vapor that are transferred from the warm ocean to the surrounding air, mostly by evaporation from the sea surface, serve as the fuel for tropical cyclones. Warm, humid air rises, expands, and cools as it cools. This causes the air to quickly become saturated, which causes water vapor to condense and release latent heat. This action warms and moistens the air column at the center of the developing disturbance. The ascending air becomes buoyant due to the temperature difference between it and the cooler environment, which further accelerates its upward motion. The tropical cyclone won't have enough fuel if the sea surface is too cold, since there won't be enough heat present and the evaporation rates won't be high enough. If the warm surface water layer is not deep enough, the growing tropical system will alter the submerged ocean, cutting off energy supply altogether. The deep convective clouds rain will cool the water's surface, and the storm's powerful winds will stir up turbulence. If the resultant mixing causes cool water to rise from below the surface layer, the tropical system's fuel supply will be cut off. Large amounts of water are frequently brought by tropical cyclones to the areas they influence. The thick convective clouds of the eye wall and the rain bands on the storm's outer borders are responsible for much of the water's rainfall. Several centimeters of rain fall each hour on average, with shorter bursts of substantially greater rates. Over some areas, total rainfall amounts of 500 to 1,000 millimeters, 20 to 40 inches, are not unusual. These kinds of rainfall totals could overwhelm storm drain systems, causing localized floods. In low-lying areas like Bangladesh and the Gulf Coast of the United States, flooding may be particularly catastrophic. Additionally, it is a concern in regions where mountains and canyons concentrate rainfall, as was the case in Honduras in 1998 when floods brought on by Hurricane Mitch's rains completely destroyed entire communities. This is all for today. Don't forget to subscribe and click the bell icon for more videos. Stay tuned with AWZ.